if you apply super in front of that intelligence, ultimately what we're trying to do is create a product, create intelligence that goes beyond what we've ever done as a human species in every domain possible all at once. Our goal is democratizing superintelligence for all. It's not just this thing that's going to sit in some lab and only be used by special folks. And I don't think that's anyone's intention today, but because that word is so undefined, even artificial intelligence, artificial general intelligence is so undefined, it can feel scary to the sort of common person. And so if Lambda can build enough compute to ultimately democratize superintelligence across the economy, that is ultimately the mission that we want to get behind.
In this episode, I talked to Robert Brooks IV, the Chief Commercial Officer of Lambda. Robert and I discussed the company's mission to build supercomputers for superintelligence, its vision of democratizing AI, and why it's beating the drum on the idea that compute is not a commodity. We also talked about why Lambda invests in research and what the research team does. We got into why all of the AI infrastructure companies are talking about co-design right now. And Robert emphasized why the company's experience and expertise in building out physical infrastructure is such an important aspect of what the company can offer. We also talked about Robert's journey in the tech industry, his $40,000 robot experiment, and his advice for maximizing your time in the age of AI. So here it is, our conversation with Robert Brooks IV of Lambda. So Robert, for those who aren't familiar in our audience, talk a little bit about what Lambda does and what your role is with the company.
Of course. So very simply, Lambda builds supercomputers for superintelligence. We are the compute backbone to the AI economy. And we have this thesis around, getting one GPU for one person in the entire planet. So we want to build billions and billions of GPUs out there. It's an ambitious goal, which is the right thing to have. In terms of my role, I'm the Chief Commercial Officer, so I oversee sales, marketing, and customer success, and have been part of the company since really as part of the founding team. So I like to say that I showed up on day 2, not day 1, like our founders. And we've had this sort of front row seat to the birth of the transformer, the neural network architecture, that ultimately led to language models and then large language models. Which back then were not as large as they are today, measured in the
Sure.
billions and trillions of parameters. And we serve that economy. And we're AI researchers. I'm one of the only non-technical AI folks on staff. And we actually build compute clusters for our own AI research as well. That's how the company started.
Amazing. How long has Lambda been around?
Technically since 2012. So our founder and CEO, Stephen Balaban, is a machine learning engineer, and built a couple of really bespoke machine learning and AI products in 2013, 2014, and 2015. These products actually look kind of like what we use today, but they were using extremely different models. So convolutional neural networks, a lot of things on like GANs and rendering. And we were creating products that essentially could do this like style transfer with a picture of you and a painting from Monet, put those two together and create this sort of surrealistic image. This was really, really cool and fascinating work in 2012. It feels like it's just like a prompt away on the Claude app or ChatGPT app today.
Of course, of course. You know, it's funny. So I remember Lambda back in those days because I was working at a very enterprise site, Tech Republic, and I remember Lambda coming up with some of the early work that you all were doing. And so, what a journey. And they say there's a lot of things that you can't control in your journey as a startup, and one of them is timing. And what an exciting run to sort of be working on that at the time when sort of this huge wave now has come, and sort of the work that you've set yourselves to, the world needs a lot more of at this moment. Yeah.
I like to tell people that in 2018 and 2019, when I showed up to customer meetings, I had to try and convince them to use GPUs for their workloads. That statement alone is insane in 2026. The dynamics have reversed.
Tell me a little bit about this, like, one GPU for every person in the world vision. That's the first time I've heard that. And what would that mean? What does that mean? And how does that vision, how do you see the vision playing out?
Yeah, so you'll see this in all of our press releases. You'll see this in a lot of our videos and content. We'll talk about one person, one GPU, and making compute as ubiquitous as electricity. These are grand visions that'll be achieved over decades or potentially centuries. But that's sort of our foot in the game. Ultimately, it comes back to why I believe what I believe our mission to be today, which is maximizing breakthroughs. So whether it's drug discovery or something related to robotics, it's going to have a massive impact into the world and our quality of life and our ability to potentially live longer. These are theses that are largely going to be achieved with the adoption of these neural network architectures and scaling compute on top of it. So Lambda's position in this concept is providing as much compute as possible to those geniuses that will do their work on that substrate. And so that is our part to play. Now we come at it from a little bit of a different angle. With our founders sort of being machine learning engineers and researchers, we understand what it takes to produce and get to that scientific outcome because we've done it ourselves. But to the point of where we actually add value back to the ecosystem, it's in, okay, we know how to build the clusters for ourselves, therefore we know how to build them for the largest enterprises and hyperscalers and AI labs in the world. And we've proved that thesis over the last 8 years. We've been a GPU infrastructure company. And today, ultimately, if we can help maximize AI breakthroughs or breakthroughs in general, then that's our position within the AI economy.
You know what, Robert, it's funny you mentioned the supercomputer, part of the mission at the beginning. And that is kind of how I think of Lambda today. When I think of Lambda, I think of that part. But you mentioned this research mission as part of what you do as well. Tell me a little bit more about that. Like, how many researchers do you have working for us? What are they working on? How does that play into sort of the economy, the economics of the company, all of that?
Yeah, of course. So it's ultimately just part of our identity and why we exist and how we feel that we can give back. So ultimately, when the Transformer paper came out in 2017, there were a few sort of infrastructure players that were looking at that and going like, wow, we're going to be able to really scale up neural network architectures. And essentially, it's almost boundless in terms of the compute that you can provide to scale these neural networks up. There's few clouds that were thinking in that way, maybe none, maybe only Lambda.
Okay.
And I think that perspective is just very different in terms of why we exist and what we're building towards. So yes, we had 6 papers published at NeurIPS in December 2025. Which I don't think any other cloud did. Of course, like I'm sure scientists at hyperscalers that are on different teams than what those core businesses are have papers published there. But like we have the exact cloud engineers that you're potentially working with when you're buying compute from Lambda, actually publishing at these conferences as well. And when we can go super deep into the stack, not only at this sort of like technical driver and framework and layer, but also into the sort of optimizing the actual architecture of the model. This is how we give back to our end users. It's not just the dollar per GPU per hour and the compute that you're thinking about. It's the value add on top of it. And that's where Lambda's special sauce is.
Tell me a little bit more about that. What are some of the things that your researchers are working on? What are the things that they, provide? What are some of the more like tangible benefits that you've seen from sort of investing in research? Because it's not, I think writ large, in many cases, we're seeing that kind of sort of investment and focus on sort of pure research is a little less, interesting than it used to be, unless you're Google DeepMind, right? And you have a couple hundred people and, they don't have to provide any economic value or whatever the case may be in there, for a company that large.
So of course there's things that we show off like from time to time. We don't show everything. But one of those last year was a concept called Neural OS, where essentially an operating system could be run by neural networks. And essentially you could create any software just by prompting it into existence within your operating system. And you can connect those pieces of software with other people that have the same Neural OS. This is a vision for the future that might not manifest itself tomorrow, but it's in a similar vein of what big AI labs are trying to build towards. So the fact that your compute provider has a similar thesis and has already gone down a little bit of the research rabbit hole to understand it probably builds trust in terms of being able to work together and supply this really important substrate to you. So that's one example. We have a lot of like Palantir style engagements with customers where we're actually, again, not just providing the end service, but sort of customizing it to them. It goes beyond the sort of infrastructure level all the way to that model level. This is helpful because AI researchers cost a lot of money and they're in
Sure.
high demand, and Meta
Yeah.
might poach them for $1 billion, right? So when you need to think about how you're going to build your business, whether that's a neo lab or an enterprise, um, you need to think about the type of partners that you're choosing along the way and their specialties. And we'll get to this concept about compute is not a commodity. This is a big part of it, right? Just handing you
Yeah.
a GPU is one thing, being able to add value on top of that is another.
Now it's time for a word from this week's sponsor, Area. Bringing AI into your company is exciting, but it can also feel risky. Between data privacy concerns, security threats, and constantly evolving compliance requirements, it's easy to hesitate. That's where Area comes in. Area provides a unified security layer with advanced threat detection and strong governance tools, designed to protect your AI ecosystem from day one. You can safeguard sensitive data, monitor activity, and stay aligned with your compliance standards, all while continuing to innovate at speed. So instead of slowing down because of uncertainty, you can move forward with clear guardrails and real confidence. You don't have to choose between innovation and security. Area helps you do both at the same time. If risk has been the thing holding you back from going bigger with AI, this is your green light. Visit area.com to learn more or start a free trial. Go to AIRIA.com. That's AIRIA.com. We thank Area for their support of the Deep View. Now, back to the show. Does that plug into one of my buzzwords that I keep hearing a lot in 2026, throughout the AI ecosystem is co-design, is like, working with chip makers, working with infrastructure providers to really optimize the compute, right? Because compute is very expensive. It's getting more expensive because of the commodity, not the commodity, but the components are getting so expensive, getting more expensive, up in some cases 600%, 400% year over year. It's crazy.
Yep.
So we're very compute constrained, and then two, it's so expensive. And it's also one of those things that we know that when there's a lot of competition, things like response time and all of that matter a lot, right? So my understanding of co-design is that, like, if you're a software provider, you want to provide something, and then you're an infrastructure or chip provider, and you've got sort of the machines to run it on, working together is what makes sort of that work really well. Is that something that you all are coming across and that I'm assuming pretty involved in?
Yeah, of course. So for companies that need tens of thousands of GPUs within a large supercomputer, you sort of have to think about ultimately where their needs are, where their orchestration stacks exists, and how they want to take advantage of such a large fabric of GPUs. And it's not just by creating a product architecture, handing it over to them and saying good luck, right? Or we'll help you a little bit with some forward deployment engineers.
Okay.
It's meeting them where they need to be, and so Lambda's done a really incredible job of that. So we do run an insanely big public cloud where anyone with a credit card can sign up right now and get access to enterprise-grade NVIDIA GPU instances or clusters. And that's sort of a set model where you sort of come in, you pay by the hour, you pay by the month, and you're good to go. It's a really technically challenging platform to just keep alive and up
Sure.
and online. And not a lot of our sort of like neo-cloud competitors have sort of gone after that market. That's where Lambda started, because that's kind of where AWS started. They started building a platform first. Well, it turns out that companies need to grow way beyond what a public cloud can offer them today, especially the big AI labs and hyperscalers. And this is where that co-design and customization comes in. And it, whether it's sort of a bare metal that's managed offering, or whether it's a bare metal instances offering from Lambda, we can find certain ways to meet you exactly where you want to be and still get the sort of telemetry and healthy metrics that we need to run a healthy cluster with a high amount of uptime. And that takes a lot of co-engineering, co-design, to your point.
Look, Lambda has the tiger by the tail right now, right? Like the amount of demand, I'm sure demand is just falling out of the sky for you all. What does the next sort of stage of Lambda look like, knowing that we're in this incredible build out period, that there are new startups coming, We've seen all the money, essentially like 50% of all the VC is being, by some statistics, is being put into AI. AI is going to need essentially what you have. So you've got demand as far as the eye can see. But when you think about the future of Lambda, when your team thinks about the future of Lambda, what does it look like? What's your all's vision for where all of this goes and the part you can play, and what is probably the largest build out that we've ever seen, in tech, and obviously you have a role to play.
Yeah, so we talk a lot about superintelligence for all. Right now, superintelligence can feel like a scary word. It's somewhat undefined.
Sure.
I have my own personal definition of it, but it's not defined at the sort of macro level.
Okay.
And I think it's actually a way more powerful word than just artificial.
I want to hear your definition too, by the way. Yes.
Okay. It's a little bit like emotional in some sense, but I can get there.
Good. Let's go there.
For me, superintelligence, well, let me back up a little bit. The word computer, when I say that word today, you just think of a box. But that was actually a word to describe a human job at one point.
Yeah.
Right? Now, take a word, intelligence. How do you think about that word? For me, it's extremely abstract. I just think of like really smart people.
Sure.
In some sense. Right? Now, if you apply super in front of that intelligence, ultimately what we're trying to do is create a product. I guess it can be called a product in some sense, but create intelligence that goes beyond what we've ever done as a human species in every domain possible all at once. So, was Edison necessarily smart in this domain that he didn't cover? No, right? And if you can create some sort of tool, better word than a product, a tool that we can leverage as humans. So we take our intelligence, combine it with the superintelligence of that tool, we're going to be able to get to drugs that we need as a species to cure illnesses that are affecting us right now. Or we're going to get towards tools or products or cars that help us get from A to B in a much more safer fashion. Or we're going to get to places within the economy that help us, move a lot faster as well. And so we're going to solve human problems with that superintelligence. And I think that is ultimately, for me, the most important thing. So intelligence will become a more human term in the sense of when we create the superintelligence tool.
Right. Your take on superintelligence, AGI, however you want to frame it. This is really becoming a bit of a litmus test issue in the tech world, as I'm sure you're well aware. Like, there's the crowd that's like, everything we're doing is to build superintelligence, which is this like thing that's smarter at any human than at a human than anything. And then there's the other crowd that's sort of like, no, these are tools and there's no single human that knows everything, right? So it's not really possible, and it's the wrong goal to try to create one model that's good at everything. What you need instead are more specific, domain-specific, task-specific models that are going to do these specific things well. So let me know, how do you think about it?
Yeah, I mean, I don't know how the future will look in terms of how the tool is built and spread. I can tell you that, well, there's a distillation of a large model into specific domains. Obviously, that seems to be the flavor du jour today. But to go back to your original question, like, our goal is democratizing superintelligence for all. It's not just this thing that's going to sit in some lab and only be used by special folks. And I don't think that's anyone's intention today. But because that word is so undefined, even artificial intelligence, artificial general intelligence, so undefined, it can feel scary to the sort of common person. And so if Lambda can build enough compute to ultimately democratize superintelligence across the economy, that is ultimately the mission that we want to get behind.
The way that looks is, if you can make the infrastructure layer affordable enough that the downstream effect will be that AI is more affordable, more approachable for everyone on sort of any device. Am I understanding that?
In some nature, I think eventually. But right now, there's still a lot to go in terms of the build out of superintelligence, right?
Sure.
And in terms of the chips that are needed to train the next model. You continue to reach, sort of these ceilings in the capabilities. And, I do believe in, scaling compute is ultimately one of the solves in getting to that new function. And so whether that's the Blackwell series that's out from NVIDIA or the next chips with Vera Rubin, or even beyond that with the Feynman series, it is our job as Lambda to make sure that those chips get deployed on time at a massive scale in the hands of the most important AI researchers in the world to ultimately affect the human species positively with that work that they're doing, whether that's drug discovery or other parts of the economy.
Okay. So that leads us nicely into this phrase that I've been hearing from Lambda lately that I like to poke at a little bit, which is this like compute is not a commodity. And the interesting thing is like the temptation is to think of it as a commodity, right? And increasingly the talk is like models themselves are becoming more commoditized, right? And then compute sits a layer beneath them, right? And so that it's essentially because what's when people say we don't want this to be a commodity, what they're meaning is because what happens when something is a commodity is it just competes on price. And so, nobody ever wants to be in a business where it's a race to the bottom and you have to just find the best way to get to the lowest price. And so what does that mean for you all, for Lambda, when you think about this? Because clearly what you're saying is not all compute is created equal. Yeah.
So just based on what I've been saying, clearly we're bitter lesson pilled here at Lambda. We believe the scale of compute is one of the biggest solves, and that's our contribution back. And so when I say compute is not a commodity, well, in the simplest way you can think about, if you've ever gone to a data center that's being built, these are massive infrastructure projects.
Yeah.
I mean, at one point in a particular large data center that we had 3,000 people concurrently working on it. I mean, the scale of that is actually really impressive.
Sure.
And if you ever get a chance to visit a data center during the build out, not after it's done, but during the build out, you're going to see thousands of different machines, thousands of different connections, thousands of like mechanical and electrical and plumbing componentry, all having to come together in order to make sure that one GPU cluster stays with a high reliability and high uptime. And in order to build these things, you have to wear a hard hat. You have to wear steel toe boots. You have to get a little muddy. You have to get a little dusty. And this is different from, just the concept of, a polished software product that's sort of been built in a glass ceiling building, an all glass building, and, handed off to you, via an API. This is real physical industrial build out. And so you can't
no other way to do it, right? Like there's no other way to do it with that. Yeah.
Yeah. And so GPUs and the availability of them, in 23 and 24, was potentially treated as a commodity. Oh, we're going to have way too many. There's stories about, AI being able to like catch up to this amount of build out, and we have concerns. And we've just continued to blow through that expectation over and over and over again. And so at the very simplest sense, from a physical industrial sense, the compute is not a commodity. Like I own steel toe boots, right? Like, when I show up to a data center, I have to wear a hard hat. These are different parts of the economy that are all contributing back towards this build out. Secondly, the way that you set up these data centers, the way that you set up these clusters, there's so many just incredible nuances and just a million different things that are happening concurrently to make these things go live. And they aren't expressed to the end user. They're only seen by the people that are actually building this out.
Sure.
And so there's, within a given compute rack, there's tens of millions of things, components that are currently working all in tandem. The build out of the data center compounds that and multiplies that even further. And the level of complexity just goes through the roof. But ultimately, it simplifies into you just being able to see that the GPUs are available, in your command. And so if I could take every single ML researcher and everybody and just show them the amount of hard work and physical industrial sense that goes into this, I would. And that would definitely expose how complex this type of system is and why it's not a commodity. I think the final thing is we saw in the news a couple of weeks ago that XAI's utilization was rumored to be at 11%. Well, there's different ways to measure utilization in clusters. Everybody took that to mean fleet utilization. They're only using 11 out of 100 GPUs. That's not what it was talking about. It was talking about model flops utilization. And so ultimately, what that's measuring is the ability to make use of every GPU within the server for a particular training run or inference run, more so on the training side. And you do that through software optimizations, model architecture, understanding all the different sort of loss curves that go into what you're building, the data that you're selecting. And this is where it gets closer to the bits rather than the atoms that I was just talking about.
Okay.
And so you have to combine the bits and atoms world and to, all of these things concurrently to get to a point where compute is actually the opposite of a commodity. It is one of the most scarce resources in our economy today.
Very good. So what does that look like? So comparing if I have, a training run that I want to do and I need infrastructure to do it, and I'm trying to pick between Lambda and one of the neo clouds, what is your pitch to say, hey, here's why you should do it with us. Here's what you're going to get, if you do it with us versus, somebody else.
Yeah. So you would never, let's think of a good example. You would never buy a service that's abstracted from you without understanding where it's currently located. So let's say, for example, you buy an airplane ticket. You don't just go on some random site and go, hey, we'll just let you know who the airline is and what airport you're flying out of, and whether or not it's a good jet or a bad jet. You pretty much trust who the provider is, and you assume that they're flying like an Airbus or a Boeing airplane, and it's going to be up to a certain level of standard. You don't have to worry about that. It's been sort of abstracted away from you. The brand is, you trust the brand. Well, in this world, when you're buying compute from different providers, you should be asking questions as to, well, what data center is it located in? Is it a tier 1, tier 2, or tier 3 data center? Tier 3 being the better one in terms of uptime and reliability. And are these data centers like former retrofits of older data centers? Are they retrofits of former crypto mines? Who's actually operating the data center? And it's an important distinction in terms of the end result that you get and what you're ultimately going to be able to do with it and your satisfaction with that service. And so it's really important that Lambda's chosen to grow a little bit slower than some of our competitors because we only work with tier 2 and tier 3 data center providers. These are providers that have been in the business for decades. These are names that you trust. I would eat my dinner off the data center floor of these. I mean, they're so perfectly built and clean and well done. I mean, these are amazing structures. And as a cloud provider, we trust these people in terms of the environments and the actual physical infrastructure that they're building. And that flows into everything that you do. The rack uptime, the reliability, the ability to meet the service level agreements that we have with our customers. And over time, if you're doing a contract with us for 3 to 5 years, these things are going to become extremely important. If you're having downtime, if you're having reliability issues, if you're having throughput issues, latency issues, there's a million ways for this to be a bad experience, right? So you book that United flight to fly to New York, and it turns out that you're on a propeller plane, and there's a lot of turbulence. You're going to have a very different experience than someone that, booked a Boeing plane and got there in 4 hours. So it's hard to explain this nuance to customers, but because the build out has been so fast, people have cut corners and go, all right, we'll just throw these GPUs into a container and we'll blow a bunch of fans on top of it. And we'll use fresh air cooling. This is a term that I've never heard before. Not just air cooling, pumped in via an HVAC system, fresh air cooling. If the wind's not blowing that day, your GPU temp is potentially higher. Those corners that are being cut are not suitable for a large AI build out. And Lambda does not cut those corners.
Robert, how did you get your start in the tech industry? I'd love to hear about. It's one of the questions I'd love to ask people. You've obviously had a great run with Lambda, but how did you end up in this crazy wild ride of an industry?
Yeah, I appreciate that question. I grew up in Cleveland, Ohio. Really incredible place to be from. Definitely strong identity with the Rust Belt and how big their economy got and then contracted. And the understanding of how that happened. I was ultimately a stockbroker out of college at Charles Schwab. There's sort of 2 routes that you can go within Schwab. You can go to the technical analysis side, which definitely fascinated me, or you can go to the sales side. And I didn't know what sales was. I just thought like talking to people and building relationships was part of the gig, and found myself in a position where I was in the 95th percentile for the metrics that they tracked in terms of lead conversion and bringing assets in. And I wasn't even trying. So it was inherently built in. Probably credit to my dad, who was, a similar, very sort of jovial and very charismatic guy. And at Schwab, I was based in Denver, Colorado. A lot of Silicon Valley and New York offices had their second offices there for engineering and sales. I was able to find Stack Overflow. I really wanted to get into learning how to write code. And so those two things meshed together. I got to live in the industry, but also, learn from the industry. And what's really funny is that Stack Overflow is one of the prime examples of a company being disrupted by AI, which is sort of interesting. But the one thing that Stack Overflow took really seriously was machine learning. At that time, we more so talked about it in terms of data science. And so the next company I went to was Tempo Automation. That was a robotic company using computer vision to automate printed circuit board prototyping. And then ultimately, I went to a hardware hacker event on a random Tuesday night in 2018 and got to meet the founding CEO of Lambda, Stephen Balaban. And they were 5 people. They needed a salesperson for one of the first non-technical hires to jump on board the crazy rocket ship that was being built. It was not an obvious decision at all. I remember meeting my wife, at that time girlfriend, and bringing her there. And she thought I worked at some cool startup with all the perks and amenities. And it was just a factory floor with a bunch of computer parts all over the ground. And so, been very lucky in some sense, but also intentionally always staying close to the engineering side and always wanting to explore what's next. Those are the key things that got me to where I am today.
One of the questions that I love to also ask people is about, in this AI era, the promise was that, we would get automation and so we'd work less, right? We could give stuff to the AI agents and they would do stuff for us. But what we found instead, at least what I found, is most people are working more. They're trying to keep up. They're trying to learn. They're trying these new things. The technology is changing so rapidly. So you're constantly in a learning cycle, a learning phase, a learning mode. And so time is more valuable than ever. You're also a leader, and so leaders talk about this in terms of leverage often, right? How do I leverage, which means how do I choose what's the best things to spend my time on? As you think about those things, what's like one tip that you have for people who are trying to maximize their time in this age of AI?
So I fundamentally believe that work is an important part of what it means to be human. You could give a lot of people $10 million and sure they could spend the next 6 months on a beach and surfing. But over time, they would want to get back to like contributing somehow. And today we manifest that in the form of a job, right? It can be manifested in any way, but ultimately it does look like something called work. And part of your identity is associated with that. And I think it's important, right? Like, I remember growing up being like, why do these millionaires and billionaires and extremely successful people are still pouring in all this time to their companies and doing all this sort of thing? It turns out they enjoy it, right? It turns out that it's scratching at the surface of everything around you has been built by someone else. And so for me, the adoption of these AI tools, I think about it very simply. I don't have any sort of magic sauce. And it goes back to my definition of superintelligence. I cannot be an expert in every single domain that I currently act in, but I am one prompt away from knowing what's going on. And that can be in meeting. That can be right before. That can be right after. That can be the research that I'm doing at night or on the weekend about that particular thing. And that is a very powerful thing to have at your fingertips. A very simple example, more so in the personal life, is if you're looking for a house, you can take the schematics and the floor plan and the square footage that they're advertising and run it past the 3 models that you choose, and all of them will calculate it, and potentially they'll say different things. And you can go back to the realtor and say, hey, this isn't 1,500 square feet. This is 1,472. So that power at your fingertips, I think, is really powerful. For me, in my professional life, I am just becoming an expert in real time by prompting. Now, of course, I can take that and build that into certain documents and spreadsheets and presentations, but ultimately be able to get up to speed on the extreme vast amount of concepts that I deal with on a daily or weekly basis. That, for me, is how I'm leveraging AI.
Very good. How about your time, the tools that you spend your time with? What's one tool right now that's making a big difference for you that you would recommend to other people consider if they're not?
It's a good question. I think I have a little bit of exposure to robotics at our company. So we bought a Unitree robot about a year and a half ago. I had some extra marketing budget, and
Cool.
we decided to take that on. And we took our machine learning team at Lambda, and we started building models and playing with it and understanding how to actually program it and get it to do things we want it to do. And I think not everyone has that experience today. I'm very lucky that a company was able to fork over $40,000 for this robot and make the investment.
Yeah, me too. Our marketing budget last year we had extra 40,000, and I also bought a robot. No, no. I'm pulling your leg. Yes, please keep going. Tell the rest of the story.
But I believe that, whether it's what 1X is doing with the Neo robot and the rumored price being around $20,000, that people are going to start experiencing that in their daily lives. Now, It's very, very simple tasks, but at the end of the day, I want to maximize my time focusing on the things that I love to do. And if this robot can just do a very simple thing that I don't want to do, whether that's loading the dishwasher, unloading the dishwasher, loading the dryer, unloading the dryer, folding the clothes, these are tasks that I don't want to spend my time on. I'd rather go hardcore into work or hardcore into leisure. I'd rather be on my mountain bike than folding that t-shirt. And so everybody talks about their exposure with LLMs and Cloud Code and all this sort of stuff. And of course, I'm doing that today. But I've been able to glimpse a little bit of the future with this robot and having something personal do something for you. And I think that's a very special thing that's going to enter our world in a very short amount of time. And it's going to have a very interesting impact in terms of how we think about the tasks that are in our daily life. And if we have more free time, what could we be doing with that? Are we painting? Are we writing poetry? Are we riding on our mountain bike more? Are we doing more podcasts, right? This is where stuff gets fascinating.
Robert, thank you for your time. Loved the conversation. Appreciate you being here on the Deep View Conversations.
Thank you so much, Jason. This was a lot of fun.